All right, today we're just going to have a quick introduction to oxidation reduction reactions, or redox. This is involving the transfer of electrons. Now, both reduction and oxidation are two separate processes, but they have to happen simultaneously. So if one atom is losing electrons, the other one has to be gaining those electrons. So mass, charge, and energy must always be conserved. Now, this happens because of a desire for electrons in a chemical reaction. We know from our periodic table unit when we talked about bonding that species prefer to either lose or gain electrons in a chemical reaction. So our two formal definitions for these two processes is that oxidation is a loss of electrons, and we can observe this by the oxidation number going up or increasing, meaning becoming more positive as it loses those negatively charged electrons. Reduction is the gain of electrons. This is observed by the oxidation number going down and reducing, becoming more negative as it's gaining those negatively charged electrons. So there's two ways to remember this. I prefer oil rig, which is oxidation is loss, reduction is gain. There is, however, another one. The Leo of the line goes GER, that loss of electrons is oxidation, gain of electrons is reduction. So pick one of the two ways to help you remember that oxidation is loss and reduction is a gain of electrons. So one way to simply identify a redox reaction is to inspect the oxidation numbers from the reactant side compared to the product side. We use oxidation numbers basically to track the movement of electrons from the reactant to the product side. So for going through this, and I'm just going to quickly kind of just give you the oxidation numbers here, and then in concept we will practice going back over oxidation numbers. But here I've assigned oxidation numbers to everything, and we can see that none of the oxidation numbers change. Na stays +1, oxygen stays -2, hydrogen stays +1, and Cl stays -1. There's no change in oxidation numbers, so this isn't a redox reaction. So double replacement reactions we're going to see for our purposes are never going to be redox reactions. However, single replacement reactions will always be redox reactions. We have Zn going from 0 to +2, and we have hydrogen going from +1 to 0. So there's a change in oxidation numbers. This is a redox reaction. A reaction is redox if oxidation numbers change for two elements within a reaction. And again, we have to inspect the oxidation numbers to decide what's occurring. Now, oxidation is the loss of electrons. We can observe this when the oxidation number goes up, meaning it becomes more positive as we take out negatively charged electrons. So for Zn, going from 0 to +2 is an example of a loss of electrons. Reduction is a gain of electrons. So going from +1 to 0 means we actually have added in negatively charged electrons, which is why we see the oxidation number going down. So by assigning oxidation numbers above, and make sure you copy those into your notes, we can see that copper has decreased its oxidation number from +2 to 0. That means that copper gained 2 electrons, which is why the oxidation number went down, and that means that it was reduced. So copper was reduced because it went from +2 to 0. Hydrogen, however, increases oxidation number in this example. Hydrogen went from 0 to +1. So hydrogen then lost 1 electron in order for this change to happen, so it was oxidized. All right. Two other terms that you need to be aware of is that the substance that is oxidized is also called the reducing agent. This is the species that basically performs the oxidizing on the other element. So in the above example, the reducing agent is hydrogen because that was what was oxidized, while the reducing agent is copper because that was what was reduced, or oxidized, in order to be the reducing agent. So the oxidizing agent and reducing agent are always located on the right-hand side. So we're always describing them based on what they're represented as over on the left. So in this example, oxidation is a loss of electrons. So we need to look at it going from 0 to +2. That means it's losing 2 negatively charged electrons, which means magnesium is what is oxidized. What is reduced is a gain of electrons, so it's becoming more negative, or its oxidation number is going down, which means that oxygen, which is going from 0 to -2, is reduced. So just remember, in this case, we're looking at oxidizing agent is what was reduced. So oxygen is our oxidizing agent. A reducing agent is whatever was oxidized. So magnesium is our reducing agent in this particular example. All right, so just review those terms. Also make sure, honor students, you're moving right ahead to concept B to look over oxidation numbers and prepare for that. But make sure, again, you definitely understand oxidation and reduction terminology because we're going to be using a lot this unit.